Perfect. Welcome to this new YouTube video. Today I will show you an interesting and classic technique in Windows malware development. We are talking about classic shellcode execution, okay? Basically, the description of this technique is something like malicious code is executed into a local process and executed directly from memory, often bypassing disk-based detection mechanisms, okay? So, perfect. Let's start. The steps to perform this classic shellcode execution are very simple. We start defining the shellcode, for example, can be created with Metasploit, whatever you want. Then we allocate memory. We use the virtual alloc function to reserve and commit a memory region with page read to write execution. And then we copy our malicious shellcode using the RTL move memory function inside our new allocated memory space. When this is done, we use the virtual protect function to change the memory protection to page execute read. So we jump from page read write to execute read to avoid page read write execution in the same memory space at once. Okay. After this, we create a shellcode. We create a thread, starting to the beginning of the new shellcode buffer where our shellcode was copied inside it, okay? When this is done, the shellcode will be automatically executed, okay? So let's jump to the virtual machine. Perfect, so here we have the code, okay? Basically, this is a calculator shellcode, okay? This shellcode will execute a calculator Windows application. So this is created with MSF Venom. That's the reason why you need always to stop the Windows Defender before execute this type of code, okay? If you want to evade this type of security protections, you can encrypt your shellcode, you can use syscalls, you can do a lot of things. But in this case, we are just trying to execute the shellcode without looking at the detection, okay? So perfect. This is the code. Basically, to understand the code, it's pretty simple. Give me a second. Perfect. So basically, let's start. First of all, we are allocating a new memory space using virtual alloc. Okay, we are committing and reserving this memory with page read write permissions. Okay. After this, we copy our payload to this memory buffer. To do this, we use the RTL move memory function, and we say to this memory buffer, to the new created memory buffer, we want to copy our shellcode. Remember, the shellcode is this variable from here that contains the malicious shellcode, and then the size of the shellcode. This size is just calculated using size of shellcode, okay? So after this, our shellcode will be copied inside the new memory buffer created with the virtual alloc function, okay? When this is done, we just need to make the buffer executable. With the virtual protect function, you can change the permissions of a memory space. In this case, from this memory space, we want to change the memory permissions to execute read. We don't need the write operation because we have already written our shellcode inside this memory space. So we just need to read and execute this memory space. When this is done, we just call the create thread function pointing to the memory buffer, okay? The start routine, the first direction, the first address where the thread will go, it's the start of this memory buffer, the memory buffer with our shellcode inside, and the result of this is the install execution of our shellcode, okay? So if we try to execute the project, the code, the result will be the shellcode that it's this calc.exe application pop-up. It's automatically triggered, okay? So let's wait a second. And if forward is good, a calculator is just executed approaching our shellcode, okay? Perfect, so that's all for this technique. Remember that you have a lot of these techniques in our malware technique database. These and two more techniques, DLL injection and classic process injection, are already free for all of you. And for the other options, for the other plans, you need to purchase one of these two plans from here, okay? So perfect, that's all. See you later.